This incredible story began on August 6, 2012. The American rover Curiosity entered the atmosphere of Mars, a planet with a thin atmosphere, harsh surface, and endless deserts that hide many mysteries and secrets. The descent of Curiosity to the surface of Mars was incredibly tense and complex. The spacecraft entered the rarefied atmosphere at an enormous speed, about 20,000 kilometers per hour, and immediately faced extreme conditions, including high temperatures and air friction. The first stage was slowed down by a heat shield, which protected the rover's body from the scorching atmosphere, followed by the deployment of a giant 16-meter parachute that greatly reduced the speed and stabilized the craft. When the speed became safe for landing, the unique sky crane system was activated. Rockets held the rover on cables, gently lowering it onto the rocky surface of Gale Crater. The wheels touched the soil, the cables were released, and the rockets flew away. The entire process lasted only 7 minutes, a time filled with tension, uncertainty, and enormous scientific significance. During its descent to Mars, Curiosity made unique observations never before obtained. The rover's cameras captured thin water clouds, dust devils, and shifting sands lifted by the wind, even at high altitudes. Descent footage showed craters, rocks, and dusty surface patches, helping choose a safe landing spot. Even at this stage, scientists received the first clues about the soil composition and mineralogy of Gale Crater, preparing the rover for future research. Thus, Curiosity was already studying Mars' atmosphere and surface before its wheels even touched the ground. Before the Curiosity mission, humanity had already attempted many landings on Mars, not all successful. Some spacecraft lost contact with Earth, others could not withstand the planet's harsh conditions. Each new mission became a lesson for engineers and scientists, improving landing technologies. Curiosity became the pinnacle of these efforts, the largest and most technically advanced rover ever sent to Mars. It combined the most sophisticated descent, control, and scientific systems, enabling exploration like never before. This mission became a symbol of human perseverance and desire for knowledge, opening a new era of Mars research. After its successful landing, Curiosity began its first steps across the rocky deserts of Gale Crater. The rover analyzed the chemical composition of soil and rocks, photographed landscapes and cliffs, and studied traces of ancient water. Each new experiment provided scientists with valuable information about Mars's past, helping to determine whether the planet could have once supported life. Curiosity discovered evidence that Mars once had conditions suitable for microbial life. It found minerals formed in water, traces of ancient rivers and lakes, and organic compounds in rocks. Soil analysis revealed sulfates, perchlorates, and other chemicals pointing to the past presence of liquid water. These discoveries confirmed that the red planet was once far wetter and more habitable than it is today, key evidence that Mars could have supported microbial life. Curiosity measured Martian temperatures throughout its mission, recording shifts from daytime warmth to nighttime cold. In Gale Crater, sunlight sometimes warmed the surface to plus 20 degrees Celsius, while at night it dropped to almost minus 90 degrees Celsius. These measurements help scientists understand the planet's climate, dust movement, and the effects of winds on the surface. They also provide crucial data for planning future missions and preparing robots for Mars' extreme conditions. Martian weather turned out to be more active than it first appeared. Curiosity observed strong winds lifting dust and sand, creating whirlwinds and local storms that shaped dunes and left characteristic tracks on the surface. Mars's atmosphere contains a tiny amount of water vapor, less than 0.03%, and sometimes this thin moisture layer condenses into morning frost or clouds. These findings help scientists understand how winds interact with the atmosphere and shape Mars's daily climate. Curiosity also became the first rover to record the sounds of Mars. Its microphones captured the whisper of Martian wind, the creaking of rover mechanisms, and even the sound of sand grains falling on dunes. These audio recordings allowed scientists to study Mars's atmosphere in a new way, complementing visual and chemical data. Mars's terrain is astonishing, and especially remarkable is Gale Crater, the landing site of Curiosity. This huge impact crater formed about 3.5 billion years ago during the period of intense bombardment of the solar system. At that time, Mars, like Earth and the Moon, was struck by countless meteoroids and asteroids, shaping craters and transforming planetary landscapes. At the center of Gale Crater rises Mount Sharp, with layered rocks preserving traces of ancient water and climate change. Curiosity studied rocks, dunes, plains, and remnants of ancient flows, allowing scientists to reconstruct millions of years of Martian geological history and understand how external forces shaped its surface. Studying Mars is important not only for science, but also for humanity's future. By exploring its surface, atmosphere, and geology, we learn to understand planetary climates, the formation of rivers and lakes, and the conditions required for life. This knowledge drives the creation of new space technologies, preparation for interplanetary missions, and perhaps even colonization of other planets. Mars is not just a window into the past of the solar system, but also a stepping stone toward humanity's future in space, a source of inspiration and scientific hope. The upcoming missions to Mars will be even more ambitious. Projects are planned to bring samples of Martian soil back to Earth, to launch new rovers with advanced instruments, and to take the first preparatory steps toward human expeditions. Scientists and engineers are working on developing life support systems, power supplies, and radiation protection that will one day allow humans to set foot on the red planet. Mars is gradually turning from a distant dream into a real goal for humanity's future. Mars continues to inspire millions around the world. It symbolizes humanity's pursuit of knowledge, overcoming challenges, and desire to explore the unknown. Each new discovery on the red planet reminds us that science and perseverance can expand the boundaries of the possible, opening new horizons for future generations. If you enjoyed this video, don't forget to subscribe to the channel and leave a like. It really helps us grow and create even more fascinating content about space, science, and future technologies. Ahead of us lie many exciting topics, from the mysteries of Mars and the search for traces of life, to upcoming missions to the moon and the discovery of distant worlds. Share this video with friends and family who are curious about the future of humanity and the secrets of the universe. The more people get involved in science, the closer we move toward groundbreaking discoveries and perhaps even the first steps on other planets. Stay with us. The most incredible discoveries are yet to come.